This video is going to be going over the rotate string Leetcode challenge of the day. This is an easy problem. And let's begin. So given two strings, s and goal, return true if and only if s can become a goal after some number of shifts on s. A shift on s consists of moving the leftmost character of s to the rightmost position. This is one of the examples it provides in the description. I'll just show you the visual. So given A, B, C, D, E, and a goal B, C, D, E, A, and we're output true because we're only shifting by one. As you can see, if we shift to the left, A is going to the end, and B, C, D, E is going to move forward. So this is obviously true because if you shift it by one, you'll end up with this outcome. And it also gives another example in the problem, the false. As you can see, like E and D have swapped in this example. So there's no amount of shifting that will ever result in this outcomes. So this is obviously false. No amount of shifting can rotate this string. The question is, how do we even solve this problem? So why don't we start off by going through um, the naive solution, which is more complicated than the optimal solution. So we're given the starter code rotate string, given the string s and the goal string. Let's begin by first getting rid of any base cases that might give us problems as we solve this problem. So as you can see, if the goal is longer or not equal, not the same length as the string s, then we have a problem, and we can't really compare them because we already know it's incorrect. So let's just return false in that case so that we don't end up having any pointers going out of bounds or any problems like that. So let's begin with making a for loop. For this solution, we're going to use an S pointer and a G pointer. Um, the G pointer is going to be initialized at I so that we don't lose track of the current iteration as we're looping through the length of the goal. Um, Here, we're going to obviously return if the S pointer ever reaches the length of the goal, then we already know, or the length of the goal is also the length of the string S as we determined at the beginning. So we're going to return true if that ever occurs, because that would have already went through every single character, meaning it's equal and it's been shifted enough. And we'll return false if we ever get out of this for loop, because if we've already done all these testing of the conditions and nothing has returned true, then it's obviously false. Um, and let's start in adding the logic. So we're going to loop through the S pointer through the length, and we'll increment the S pointer as we're going through. And the S pointer is the pointer for the string S. So we're going to be checking here if the goal at the G pointer is equal to the S pointer, meaning if these two characters are the same, then we're going to keep iterating. And we're going to kind of just shift the G pointer, but we can't just increment it because then we're going to go out of bounds. So we have to use modulus with the length of the goal string so that we can reset the pointer to the beginning if it ever goes outside of bounds. The only thing we really care about in this problem is the S pointer, because the second it's reached the end, we're done, and we can just return true. So this is the finalized code for my solution that I came up with for this problem. Um, so what's the complexity of this solution? So the outer loop is going big O of n times, where n is the length of s, and goal as it iterates through each of the starting positions I in goal. And the inner loop is for each starting position. The inner loop, the inner while loop, can also run up to big O of n times as it attempts to match each character of s with the rotated goal substring. So it's just big O of n squared because uh, two loops inside of each other usually results in big O of n squared in the worst case. Um, Space complexity in this case would just be big O of 1 because we're not really allocating any data structures. We're just using pointers to solve the problem. So yeah. Now the question is, can we do better? Um, yes, we can. If we were to start with the same solution, we simply can just check the same initial base case if the lengths are equal and then return false. Otherwise, we'll just get a doubled string which is just the concatenation of the first string s, and then we just simply check if the doubled string contains the goal. And I know it seems really chill compared to the first solution, but yeah, this is one of the most optimal solutions you can come up for this problem since it's an easy problem. Uh, the time complexity would be big O of n, and the space complexity would also be big O of n for the length of the string is being doubled. And yeah, we just finished today's Leetcode problem, rotate string. Thanks for watching.